Hey, what is up? Good to see you again. And I thought I'd make a video about converting my old Anet A8 printer to a Bowden one. Now what got me started in making this conversion was actually the heat throat of the hot end giving up and snapping in half. And I thought I'd have to replace quite a few parts on the hot end. And then I got the idea of buying a completely different hot end and actually converting this printer into a Bowden one. The reason I wanted to do this was to get the advantage of higher printing speeds and smaller jitters due to less weight being in the extruder carriage. Right, so the parts that I ordered for this conversion included a J-Head Hotend Extruder version 6 clone. This is from Amazon, cost me around 20 bucks. And it included the whole hot end as well as the heating block, the fan, nozzles, heat throats, as well as the PTFE tube for the filament and a PTFE tube mount that has a fitting thread for the stock stepper motor that the Anet A8 extruder has. Now while I was at it, I also ordered some Drylin IGUS bearings because the old ball bearings in the Anet A8 were getting pretty whiny, as well as another MOSFET for the hot end. Previously I only had a MOSFET installed on the hot bed. And in order to complete the hot end assembly I also need a carriage, and I found the perfect one from Thingiverse by a user called Don1337, and this is called Anet A8 E3D version 6 Bowden carriage. I'll leave a link for it in the description. Having all the parts and correct length screws ready, I headed for the E3D Online's website and checked the version 6 all-metal hot ends assembly guide. I assembled the print head and did a test fit by building the whole hot end assembly on my table. After completing the test fit, I also went ahead and changed all the slide bearings on the X and Y axis. This doesn't have anything to do with the Bowden conversion, but I figured it was an easy upgrade to do while working at the printer. When everything had been test fitted, I took the extruder carriage apart and started by attaching the base plate to the slide bearing housings. The print head assembly was secured in place by tightening the holder piece onto the base. This also acts as a mount for the print cooling fan. Now it's also a perfect time to screw in the X-axis belt holder. Next, it was time to attach both the hot and cooling fan as well as the blower fan for cooling the prints. And finally, I reassembled the extruder motor and attached the bottom tube fitting to it. The fitting that was in the extruder kit matched the thread in my extruder motor perfectly. I also adjusted the screw acting as the axis of the filament clamp and made the fit a little bit tighter because the clamping mechanism was a little sloppy. To attach the extruder motor on top of the frame, simple double-sided tape was used. A note from the future, it works very well. After attaching the Bowden tube to the motor, I inserted filament in order to test the extrusion. I marked the edge of the filament and then extruded exactly 50mm of it. The extruded bit actually turned out to be 53mm long, but I wasn't too worried about this over extrusion. While editing this video, the printer had been printing for a good total of around 10 hours without me touching the extrusion settings, and all the parts have turned out really fine. The only setting that needs to be addressed before the first print is the retraction setting. Previously, my retraction was set to 6mm at a speed of 50mm a second. I left these values in when I initially tried the new hot end, and it immediately got clogged due to the hot filament being pulled too far up into the cooled part of the print head and solidifying there. I had to change the heat throat to a new one and unclog the nozzle before trying again, this time with a more settled 2mm retraction distance and 25mm a second retraction speed. These values have been working fine ever since. After calibrating the printer, I did my first successful test print, and this was just a ring with a large diameter to ensure the bed was level. The ring turned out just fine, and I proceeded with printing a phone holder I found on Thingiverse as well as a connector plate for my future project. Both parts turned out really well, but I wasn't happy with the print speed, since I was still printing with 50 to 60mm a second print speed that I had previously used. So I went up the print speed, first to 80mm a second, and then later all the way to 100mm a second. Ever since the first tests, I was stuck with the 100mm printing speed, and I'm very happy with the results. This printer has never had the prettiest print quality in the world, but it gets the job done, and now it does it with twice the speed. Trying to print something with 100mm a second nozzle speed would have not been ideal with the previous print head that had all the heavy parts in the extruder carriage. For me, cutting the print speed in half has definitely been an improvement that has been worth to do it. The quieter print noise from the IGUS bearings is also a nice thing to have, and I'm sure they will handle the rapid print maneuvers better over time. Right, thank you for watching, and if you have any questions, make sure to leave a comment. I will be sure to answer them all. And also, if you are interested in 3D printing robots, I might have a short and interesting series for you on my channel. See you in the next one.